Hello, welcome back. We are talking today about solving simple equations, topic 8-1. You did solve simple equations last year. That means involving one step. So this is kind of a review topic for our rest of our topic that we'll be continuing. So first of all, we have the launch here that says a shaky egg bagel baker just wants to keep things equal. What should he charge for one bagel to match his crosstown rival? Write and solve an equation to help him out. Explain your reasoning. So I know that a lot of you are looking at this problem thinking, I can solve this without an equation, but we need to get into the habit of writing equations. We start small with just one-step equations, and then we'll be moving up into 2, 3, 4, distributive property, variables on both sides. So we want to start small and make sure we understand this. So they say here that he charges $7.80 for a dozen bagels, and we want to figure out, obviously, the cost of one bagel. So we have our let statement where we're going to decide what variable we're using and what does that variable represent. So they want us again to find what should he charge for one bagel. So C is going to be the cost of a bagel. My equation, I know that if I have 12 bagels times the cost of one, that's going to give me the cost for the dozen. So that's my equation. 12C equals $7.80. I divide both sides by the 12, and I will get C equals 65 cents per bagel. So what we have here is our key concept that states that solving equations, you can think of solving an equation as transforming the equation into a simpler equivalent equation. Your goal is to use inverse operations and the properties of equality to isolate the variable on one side of the equal sign. So whenever we do something to the equation, whether we divide both sides or multiply or subtract, we're always trying to do something to make our equation simpler, take away a step. So here's to remind ourselves, we have the addition property of equality that states if you add the same number to each side of an equation, then the two sides remain equal. So they're showing us here that in arithmetic, 6 equals 3 times 2. It's a basic equation without a variable, that's fine. If you were to go ahead and add 5 to both of those sides, your equation still remains equal on both sides, equal to 11. They're then showing us algebraically, which just means with letters. So if we have A equals B, then if we were to add C to both sides, we would still get an equivalent equation. Same goes for subtraction. If you subtract the same number from both sides, or each side of the equation, the two sides remain equal. So example number 1 states that you can think of an equation as a balanced scale. When you do something to one side of an equation, you must do the same thing to the other side to keep it balanced. That really is our key concept, that you must perform the same operation to the other side as well. So they're giving us this equation of 3 plus x equals 11, and they're also showing us visually, and they're saying that each of these add up to 3, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Each of those add up to a total of 11. Now the equation, it looks a little bit different because they don't have it written as x plus 3 equals 11. I feel like if the equation was written like that, you would know that you would just subtract 3 from both sides because the opposite of addition is to subtract. So just be careful that we are still subtracting because this is technically a positive 3. So the opposite of a positive 3 is to subtract 3. And how I'm showing my work is the expectation of how you should show your work as well. So the 3's cancel out, and then we're left with x equals 8. We would get the same answer over here on our scale. If we think about keeping the scale balanced, if you remove 1 on this side, you have to remove 1 over here, and so forth. Remove 1, have to remove 1. Remove 1, have to remove 1. We're left with x equals 8. Number 2 is asking us to solve and check this equation. So to solve it, this time I have b minus 2 equals negative 10. So I'm going to, instead of subtracting 2, add 2 to both sides. I'm left with b equals negative 10 plus 2. 10 bad guys, 2 good guys. Bad guys are going to win, and there are 8 more of them. So it's going to be b equals negative 8. The check, and I know it seems silly to do the check with just a one-step equation, but you can use this check for equations that are multi-step, which is helpful. The check states that you're going to rewrite the original equation. Then we take and substitute our answer that we got for b in place of the b. So now I have negative 8 minus 2 equals negative 10. I am trying to decide, is the left side equivalent to the right side? So negative 8 plus negative 2, is that really equivalent to negative 10? Yes, it is. Since my two sides are equivalent, I know that this checks out. The notes continue on to talk about the multiplication property of equality and the division property of equality. They again both state that if you multiply each side of an equation by the same number, the two sides remain equal. Same thing with division. If you divide both sides by the same number, again, the two sides will remain equal. But I want you to notice again, they're bringing up that statement, if you divide each side of an equation by the same non-zero number, because remember, we can't divide by 0, that's undefined. So question number 3 is asking for us to solve and check. Now, the reason we're putting the line down the equal sign is to remind ourselves that there is two sides of the equation. This is read as d divided by negative 5, or you can think about you're trying to cancel out the denominator of negative 5. Well, how would you do that? You multiply by negative 5 first, because can't I cross cancel them? If I'm multiplying by negative 5 to the left, I have to multiply by negative 5 to the right, which will give me 7 2/10 times negative 5 gives me negative 36. Then I will check my answer by again rewriting the original, which was d divided by negative 5 equals 7 2/10. I then take and place the negative 36 in place of the d. And so now actually calculate this out. A negative divided by a negative is a positive, and then double check, you can use your calculator, if 36 divided by 5 does give you 7 2/10, which it does, so we know that this checks out. Okay, so this is your check. For the second one, some people might try to answer this question too quickly, but again, you're still going through the motions. You're trying to say what times negative 2 is going to give you 1. So we're going to undo the multiplication by doing the inverse operation of dividing. And because that is a negative 2, I want to make sure that I divide by negative 2 as well, because I want that variable to end up being positive. So when you do this, you're really just left with p equals negative 1/2. And I just move my negative sign up to the numerator. You can also write your answer as a decimal. That's completely fine. And then our check again. You rewrite the original problem. You substitute the value you got in there. So negative 2 times negative 1/2. So that's 2 over 1. I can cross cancel. And I have a negative times a negative, which gives me positive 1. So woohoo, I know that it checks out. Go ahead, do number 4. Okay, I got an answer of m was 5 5/10, and my check does work out. So for the next question, number 5, we have 4 separate equations here, and they would like us to determine which equation is different than the other. If you have any fractions, you are welcome to change them to decimals if you'd like, and you are also able to use a calculator. So please go ahead, pause the video, work on those. Okay, so I went through, calculated all 4 of the solutions, and I got the last one got negative 5 instead of 5. Right, I just want to show here that when it comes to when I multiply both sides by the same number, I like to show parentheses to show my multiplication, just in case I have decimals. Number 6, same deal. They're asking for 3 equations, have the same solution, so which equation has a difference? Go ahead. Okay, I changed my mind on this one. I want to work through the last one with you. There are multiple ways to solve it, but it says 5w equals 1 1/4. So I know that I have to divide by the 5, and that means I've got a mixed number that I'm going to need to divide a whole number by. So I'm going to just rewrite this as 5w equals 5/4, and then I will divide both sides by 5. That 5 cancels out, and then I can either rewrite this problem as a division problem with the actual division sign on the side, or I can say, okay, I'm going to use the LCM. So that needs to be a little bit lower. So I'm going to multiply the numerator by 4 and the denominator by 4. That leaves me with 5/20, and 5/20 reduces down to 1/4, which is the equivalent to 25/100. So the only one that would be different would be the third one. And then the last one is saying which equations have the same solution as 2 and 5/10 equals 30. So you really have to calculate 3 different equations. Go ahead. All right, I got that both equations are equivalent to the 2 and 5/10 equals 30. I just want to be clear with the first one, when you have 4/3 a equals 16, when you have a fraction times a variable, to cancel out the fraction that's being multiplied by the variable, you can just multiply by the reciprocal. And remember, when you multiply reciprocals, you cancel out to get 1. So some of you might have written that as, I'll do it right here, 4/3 a equals 16. Some of you might have actually written that out as divide by 4/3. You just have to do the extra step of rewriting it as multiplication and using the reciprocal. Okay? If you have any questions, please be sure to ask. We will see you tomorrow.